A line AB is run in any quadrant, say it is in northeast quadrant. The length of line AB is L and its reduced bearing is theta. If this line projection is parallel to meridian, that is known as latitude, this latitude of the line is L cos theta. This projection of a line is lying in north-south axis. If this projection is lying perpendicular to this meridian, so that is departure, that is equal to L sin theta. The latitude is lying in north-south axis and departure is lying in east-west axis. If the latitude lying towards north, it is taken as plus sign, and if it is in south direction, it is minus. Similarly, if departure is lying in east direction, that is plus. If it is in west direction, that is minus. In quadrant wise, the latitude and departure are written as plus plus. In the northwest quadrant, latitude is plus, departure is minus. In the southwest quadrant, latitude is minus, departure is minus. In southeast quadrant, latitude is minus, departure is plus. In a closed traverse, say A, B, C, D, E, A is a closed traverse. If the ending point of this traverse doesn't meet the starting point, there may be a gap arises. So this gap is known as closing error or error of closure. So to balance this traverse, you should have to apply the condition algebraic sum of latitudes must be equal to 0, algebraic sum of departures must be equal to 0. After applying this condition, the small gap say this is bearing sigma L, this is sigma D. This is a gap or not closing portion. L is equal to square root of sigma latitudes whole square plus sigma D whole square. Similarly, reduced bearing theta is equal to tan inverse sigma D by sigma L. Relative error of closure is defined as the ratio of error of closure and perimeter of the traverse. Relative error of closure is equal to error of closure E divided by sum of all the sides of the traverse. There are mainly two methods used for balancing a closed traverse. One is Bowditch rule, second one is transit rule. Bowditch rule is also known as compass rule. This Bowditch rule is applied when the linear measurements as well as angular measurements are equally precise. In case of linear measurements, the error is directly proportional to square root of length of the line. Say L is equal to length of line. In case of angular measurements, error is inversely proportional to square root of length of the line. As per Bowditch rule, correction in latitude of any side can be written as total error in latitude into length of the that particular side divided by perimeter of traverse. Total error in latitude can be written as sigma L, length of line is L, perimeter of traverse is equal to sigma L. Correction in departure of any side is equal to total error in departure into length of that side divided by perimeter of traverse. Total error in departure is sigma d, length of line is small l, perimeter of traverse is sigma L. Next one is transit rule. According to transit rule, linear measurements are less precise than the angular measurements. In this method, correction in latitude of any side is equal to total error in latitude into latitude of that side divided by arithmetic sum of latitude. Similarly, correction in departure of any side is equal to total error in departure into departure of that side divided by arithmetical sum of departures. Consecutive coordinates. The latitude and departure of any station with respect to preceding station are known as consecutive coordinates. These are also known as dependent coordinates. Independent coordinates. Latitude and departure of any station with respect to a common origin of coordinates are called independent coordinates or total coordinates. In case of consecutive coordinates, the latitudes or departures may be lying in different quadrants, so that this sign conventions may be plus or minus. But in case of independent coordinate system, all the latitudes and departures brought into one quadrant, say that is in northeast quadrant, therefore all the sign conventions of latitudes and departures will become positive.